All right. Hello and welcome everyone. Thank you for attending today. It's glad to see everybody here, excited about data and data lakes. Real quick introduction, I'm John Steinert. I run our global data services for AWS within the Accenture Business Group. My coworker Dan here is also going to be presenting a little bit later. I'll let him introduce himself at that point. So one of the things that I want to do is really start out talking about what it is to get into this and what the market situations actually look like. So when we talk about digital disruption and we talk about the actual amount of data that we look at and how much is actually created, we're talking about nearly 2 megabytes of data coming across per second per person on this planet. It's incredible. This is doubling or more, and it continues to grow. This 25% is likely already outdated, and we need to figure out how we create democratization, monetization, and value out of this data. We need to be able to do it for our businesses to be able to grow, for consumers to be able to consume in a better, smarter, faster way. So when we look at the actual market size, we're over a $20 billion market. It's incredible. The amount of capital that's tied up in this trapped data is actually worth way more. And we're looking at how we actually do this by reducing cost, by bringing in IT spend, and also freeing that data into a more open platform. So when we start looking at these things, we really want to say, what are the challenges? How do we do this? So there's quite a bit of challenges that come around with this, where we talk about cloud native services, our packaged data services, how they all come together. So we talk about our skills. Who has the skills to do this? How do I find the people to do this? How do we build out that functionality? How do we have and find the primary data sources? How do we know what's in those data sources once we get them? So we have to identify all those people. We have to start to free that data. We have to understand the metadata around those components. And we need to figure out how we're actually going to bring all this stuff together. So we have extremely complex security. How do we simplify that? How do we create ETLs where we talk about transformation and a more configuration-based or solution-based approach, rather than saying, how do I take this one little piece of data and transform it over into this piece of data, and I'm going to use this for X or Y? How do I solve the business problems behind it? How do I identify those business problems? How do I then look at maintaining costs or keeping cost controls in? Because these things can get very expensive if you're not paying attention, or if you're trying to do this at a scale that you're not ready for. The other problem that we have is, if you look at on-prem, you have a very limited, finite set of resources. If we do this in the cloud, you essentially have infinite resources, assuming that you're doing this in a microservices or solution-based fashion. We also want to make sure that we're not tying into, essentially a bad marriage. You want to be, looking at your long-term commitments to your main cloud providers, to your main service providers, and you want to make sure that you're doing this to create that long-term value. You want to be looking at, figuring out how you do consuming all of your data. You don't want to leave data unconsumed. You want to make sure that you're finding that value realization and creating optimal value. You don't want to be creating suboptimal value out of data that's not important. So when we talk about this, we want to talk about how we bring this into cloud native, how we do this with cloud native microservices, and how we do this with core tenants in play. So what we do is we have 6 core pillars. With this, we're talking about automation. So we want to make sure that we have appropriate structure underneath our S3 buckets. We want to make sure that those are done through provisioned in an automated way. We want to make sure that there's very little human interaction there. We want to make sure that that data is very secure. We want to make sure that everything is scheduled. We don't want to have this essentially running or not running unattended. We want it to be running as it needs to. So if it's real time, near real time, or batch oriented, we want those to happen based on an event. We want to make sure this whole framework is parameterized so that we can deploy this very rapidly into your development environment, to your test environment, to QA, so on and so forth. We want to be able to do it one time, all as infrastructure as code and config as code. We want to reduce that deployment life cycle. We want to bring that to as short of a development cycle as we can. So we do a lot of AWS CloudFormation, and we do that all with, through automated deployments with code build, code pipeline, and Dan will talk a little bit about that more in a few minutes. We want to make sure that we also are only doing automated file movements. We don't want people, again, moving something from landing to raw. We don't want anybody being called 10 years from now when you retire or when you get a new job and this one ETL stops working and half my business no longer is able to run because one person was moving those files every day. We don't want that. We want to make sure it's all automated. Again, everything being event-driven. And we want to make sure that every single file that lands has the appropriate quality and controls around it. So we want to make sure that there's proper checksums. So we want to make sure that there's proper security with encryption, KMS, and other tools like that. So what does this all bring us? So we talk about what a data lake accelerator can do. We want to be able to get to market faster. We want to be able to deploy this very quickly. And we want to do this with pre-configured tools. So we want to be able to ingest from SAP. We want to be able to ingest from Oracle. Or maybe it's another JDBC connector or something like that. We want to be able to take those very quickly, move those from your source into that lake, and get that data being processed as quick as we can. So we want to talk about onboarding. How will we do that? We want that speed to market. We want to only pay for this when we need it or when we're using it. That's why we look at event-driven microservices. We want to make sure that we're, again, controlling costs. So how do we do that? Again, with AWS services, we're not tying into expensive contracting. We're not tying into large commitments. Typically speaking, a small team can manage this at scale. When we look at storage, we're a little over $300 a month for 10 terabytes, may even be less, as AWS continues to drive down the cost of storage. We want to scale this to tens of thousands or even hundreds of thousands of jobs a day. We want to make sure that this is available all the time. So we're looking at least 2 nines of durability and availability. We have 11 nines of durability on our storage out of the box because of how S3 works. We also want to make sure that we're able to do this, again, that complex security piece. How do we do this? Dan will talk a little bit about lake formations and controlling that. But again, we want to make sure that we're also in compliance. So we have multiple levels of security where we have level 1 essentially being public data. Level 2 being you might make the local news if this happens, and it happens to get out. So there's zip and encrypt, there's PGP, there's also KMS, there's quite a few ways to do it. Then we have you're going to be on Fox News and CNN level. Don't want that out. So we require certain levels of security around that, as well as IAM controls, single sign-on, and essentially empirical permissions. So when we start talking about all those pieces, how does this journey actually begin? How does it go? So we talk about phase 1 being this rapid data lake build out. We want to get this into our dev environment. We want to get this into the hands of our engineers, and we want smart data scientists looking at this as quickly as we possibly can. So stage 1 being in that phase, we want to be able to get that out there. So we have a team of DevSecOps people to make sure that we have, again, the infrastructure as code, config as code, ready to go. We want to be able to deploy that into your AWS environment as quickly as we can. We want to make sure it's modular so that if we need to extend this to other tools, it's very easy to do that. Again, that event-driven architecture, making sure that we can scale this essentially to the limits of AWS. Unfortunately, we did take down US East 1 one day. That was a great time. That was definitely a day of infamy for us when we broke glue. And again, we want to make sure that we can ingest these files. So we're looking at, again, core tenets: speed to market. We want to make that as quick as we can. We want to drive our times to insights down. We want to make sure that we have very flexible architectures to build into our other tool sets out there. So let's say AWS brings out something new or announces something today at reInvent. How would you build that in? Again, most of these are very easy to build in through message passing or through an eventing architecture with some of the tools Dan will talk about. And again, keeping those costs in control. Then we want to scale this. So we want to adopt governance. We want to make sure that we know exactly what's in there, what it's doing, why it's doing it. We want to be able to track that lineage. We want to be able to define who can see it, who can access it, who can control it, and how we're going to enhance it. So how is that enrichment going to make or solve business problems? And again, we want to make sure that we have high trustworthiness. We want to make sure that we have the ability to create new data sets, so that polyglot data. We want to take something and make something new. And we want to start driving decisions for the business with this new data. And that drives us into that evolved lake, where we're talking fully managed and governed. And we're looking at this as several months to go from phase 1 to phase 3. So this is very quick to get to market. Governance and collaboration are critical pieces. So we have to identify those, the correct people to help us make this happen. And then we want to be able to transform this, and we want to democratize it so that anybody in the company with the right level of access through, whether it be Active Directory and single sign-on, or through IAM roles and other policies, to be able to go in and start driving data so that we don't have to rely solely on data scientists. And what I'll do is I'll talk about one of our global pharma companies that we've deployed this at. We're doing over 25,000 executions per day. We're actually a lot closer to 100,000 per day at this point, and we continue to drive that number up. We've created well over 25 integrations with AWS Glue. We've enhanced essentially AWS Glue 1.0 to the newer versions of Glue that you know and love today with Glue 2.0. Based on this client's feedback, we were able to work with AWS and bring these things to market for everyone. We've also started to drive down the cost of getting to AI. We can actually implement an AutoML workbench within 30 minutes of ingesting the data. So we can start to derive insights within the same day that we're ingesting it. And we've also been able to save them nearly $50 million in just licensing costs. So if you think about that $50 million, all of a sudden becomes free capital to start innovating. The value that you've created there doesn't even start to touch the data that we've started to actually bring forward. So we've been able to also create value where there was none. And we're doing this now within one of our financial reports, which actually was somewhere in the neighborhood of like 90 days from T-minus 0. It now executes within 3 hours of T-minus 0, where it used to be 90 days. We've taken their average financial reports also from about a 4-day period average to under that 3-hour window. So at month end, they're realizing the revenue much, much quicker. So with that, I'm going to turn this over to Dan and let him introduce himself real quick, and we'll talk about the architecture.
Thanks, John. So Dan Grube, I work with John at Accenture in our Accenture AWS Business Group, helping run the data practice. So one of the lead data architects on the team. I've worked with this product solution accelerator for quite some time, and excited to be here today at reInvent in person, finally, to discuss some of the details with you. So when we talk about the reference architecture for the data lake that our accelerator deploys, we really want to reiterate, as John mentioned, that we focus on serverless technologies, managed services, to not just reduce costs for the customer, but then also to enhance the scalability, resilience of the data lake itself. And we're able to stand up our data lake very rapidly through the use of IAC, infrastructure as code, via cloud formation. So it's something, as John mentioned, very, very quick to deploy, and it is very, very scalable. We parameterize the data lake itself, so it's not just something that's comes in a box and you get what you get. We're able to leverage our parameterization and make that really beneficial to the client, in that we can very specifically address the needs and the use cases of each client in each situation. So looking at the reference architecture here, I like to think of it as sort of the flow, right? So how the data flows through the data lake, what that looks like, and what different services we leverage to interact with that data, to manage that data, to store that data. So if we go from the left to the right here on the screen, we've got the capture, curate phase. We're running ETL jobs to transform data, running business logic, getting it to the final state where we're in the consumption phase, which allows us to run our analytics and visualization tools at that point. So if we think about the different types of data sources that we're able to ingest into the data lake, it's completely open. We have so many different options, often connecting with CRM systems, ERP, I'll talk about SAP in a little bit, Salesforce, any popular third-party tool or service we're able to ingest data from. And the way we're able to leverage the AWS services, cloud-native services, to ingest that data, bring that into the data lake, we use services such as Kinesis for streaming data, AWS Data Pipeline. If it's a simple file transfer, the AWS Transfer Family, SFTP. We also have built connectors for Confluent Kafka, MSK as well, managed services for Kafka as well, ingesting PubSub streaming data. And then some maybe specialized services we can also leverage, Poly for text-to-speech, and then recognition for image and video processing. And then when we, not only do we need to ingest data, on an ongoing basis, right? There's times where we have some existing data set, data store, multiple different databases where we need to ingest from at a single go. So we'll use services such as SMS, Snowball, if we need to physically move data on a device, or literally have a truckload of data via Snowmobile. And then database management, migration services as well to bring that data in. And then once we have the data, we typically push it into S3. As John mentioned, extremely durable, reliable, inexpensive. We also have the opportunity to store hot data, of course, in standard S3, and then push colder data to Glacier or Deep Glacier, as the case may be, as the life cycle process proceeds. And when we get into the data lake itself, we typically set up 3 different zones, right? So we've got raw, transformed, and provisioned. So when we move data from the raw zone, our first S3 bucket, we use services such as step functions to orchestrate the data flow, AWS Lambda and Glue. Glue helps us move data, running ETL jobs, whatever is needed to get the data into that next transformed phase. And then we leverage DynamoDB as our rules engine, configuration store for this orchestration engine itself. And once we have started moving that data, right, we get to the provision zone. This is where we're pretty much ready for analytics. So we might have data still in a S3 bucket. We also might use RDS if relational databases are of interest. Many of our clients use Redshift, petabyte scale data warehouse, extremely efficient, fast, reliable. I think I just saw in the keynote this morning that now Redshift as a service is an option as well. Once we have the data ready for analytics, we can then use SageMaker to do some ML, machine learning, against it. Neptune, if we need to use a graph database, OpenSearch, or used to be a slightly different service that was renamed. So we're able to use full text searching on the data as well. And then Athena is a super popular tool as well, of course, to query data via SQL in our object stores in S3 directly. And then as we get into the visualization aspect, we can certainly leverage QuickSight. And there are other options as well, but I wanted to leave this slide as AWS-specific services that we deploy. And then overall, the entire data lake, we have data management in place, right? So using crawlers to store metadata and schemas into the AWS Glue catalog. As John mentioned, security is of utmost importance, so IAM for users, roles, policies to put security in place, many different options as to what level of security that we decide to go with. Also use bucket policies if needed to add an extra layer of security. And then of course KMS, Key Management Store, and Secrets Manager for secrets that we need stored. And then those can of course be accessed programmatically, encryption keys and whatnot that allow us to leverage those throughout the data lake when we're transforming and still keep that data secure. So John mentioned in passing Lake Formation, right? So Lake Formation is an AWS service that was released in mid-2019, and has since become very popular. It's a service that allows clients to quickly set up very secure data lakes within AWS. And so we work very closely with the AWS team and get the new insights of the latest features and updates that are coming out. So we were able to work with them and integrate Lake Formation into our data lake accelerator. And that allows us to move from our standard role-based access controls, as mentioned, via roles and policies, bucket policies, to actually leverage Lake Formation itself, which has its own access control. And the benefit there is when we were using role-based access to S3 buckets, for example, you can restrict access to the bucket level. You might go down to the folder level. Of course, you can restrict to the object level, but then you're getting very messy. It becomes very complex and very difficult to manage as the life cycle of the data lake progresses. So leveraging Lake Formation allows us to bring data in. We automatically set up the S3 buckets, register them through Lake Formation, set up the roles and permissions necessary to access that data. And then the Lake Formation access control itself handles the security of that data, which is stored in the Glue catalog, allowing for not just database and table level access, but column, row, and all the way down to cell as well. And it's much more easily managed within the AWS console. You can use CLI if you need to, SDK as well. So it's been a real boon for us to be able to leverage Lake Formation and use its granular level of access control much to our advantage. We have many clients who have different use cases that require different security around their data sets. So this has been a great tool for us to integrate. Another very popular tool that's come out or process, machine learning. So we've heard a lot about this in the past. It used to be the case that if you wanted to do some advanced machine learning to predict data, predictive analytics, you used to have a team of very smart data scientists employed in the group to build out those models and to continually test them, to tune, to train. And it's quite a level of effort for companies to do. And oftentimes you might have a smaller company or a smaller group that's not interested in maintaining an entire staff of data scientists. So when AWS came out with SageMaker Autopilot, so we have integrated Autopilot into our data lake accelerator, and we're able to leverage the benefits that Autopilot provides in that it really eases that machine learning process, where you don't have to have all these data scientists on staff and dedicated to building out these machine learning models. So it takes data that's existing. You select a column that's going to be your Y value, and it allows you to automatically generate multiple models, and then SageMaker itself, Autopilot, will select the best fit for your data set, and then allows you to continuously tune and deploy that going forward. And this is just example of how the architecture looks within our accelerator, the way we designed the integration. So we've got the data lake on the left with primarily the S3 buckets where we're storing the data. It might be the provision bucket, the transform bucket, wherever the data is getting fetched from. Lambda function will trigger, grabs configuration information from our DynamoDB or configuration store, and then we'll dynamically create a step function workflow. And within that workflow, a glue job will kick off, not really cleansing the data, but making it, getting the data in the shape that Autopilot will be able to ingest and create the model. So removing nulls, I think there's a 500 row limit minimum that the data set needs to be in order to get to realize value out of your predictive model. So once that data flows into SageMaker Autopilot, we would get the model, and of course there's an endpoint within AWS that we can use against our other data sets to, again, predict future data trends. But we also went sort of a step further using code build to deploy that model, grab that endpoint, and publish it in an API gateway to be used outside of our environment if needed, when other data scientists might need to come in and create some new data sets using that model. So this is all, again, all CloudFormation, so it's very easy, quickly to deploy. It's been a fantastic tool for us to offer to clients. So I spoke about SAP just a little bit earlier within our ingestion framework, right? So obviously one of the biggest ERP systems out there. Many businesses are very well invested in the SAP ecosystem. It used to be the case that it was so complex, and the data models that SAP would run with were so challenging to extract data from, right? So it became a automatic silo, right? If you're going to have a bunch of data in SAP, chances are that data is going to be siloed because it's not easy to extract that data and bring it elsewhere where you might need some analytics to run against it. Bring it into a data lake that is a more cohesive data liberation area. So we have worked with our SAP team, with AWS folks as well, and developed a SAP Data Lake Accelerator, which sits on top of our existing Data Lake Accelerator. And what we've been able to do is within SAP go in, and we've created different tool sets to enable the data models to be extracted such that we can grab that information via API microservices, as John mentioned, grab that information, and then be able to finalize our connectors within the AWS side to get that data out of SAP. And this has really been huge for a lot of our clients, because previously you'd have to have many different integration tools built out, very specialized, and as things change on the SAP side, then we cannot connect to those data sources anymore. So we're able to dynamically update that information via API and set those endpoints, grab that data as we see fit, and very, very efficient. And I should mention as well, John brought up code CI/CD. So all of our processes handled through CI/CD, so we have continuous improvement delivery. So as we move from dev, say, to test, QA, prod, we ensure that that data flow is automatic, leveraging code pipeline, code build, code deploy, to make sure that we are consistent and maintain a DevOps flow within the different environments. And so what this allows us to do, I mentioned, we're able to create value by bringing a single source of truth for the data. So your data lake is your source of truth. So you don't have to go to different sources, go to SAP separately and pull the data. We're corralling it all in one place. And as I mentioned, it's very quick to set up. We're enabling analytics through the standard data lake process that I'll bring up a slide in a bit here. And it just allows for us to move kind of from the SAP environment to a more cloud agile environment to be able to analyze and then visualize data. And what that looks like from an architecture standpoint, we've been able to sort of take two approaches. We had previously built out, and this has SAP HANA. We also do ECC and BW as well. But through the application layer using ABAP, we're able to extract that data. We can also push it through Kinesis, through SAP SDK, leveraging the NetWeaver gateway. And then we've also been able to more recently develop an SLT extraction that enables CDC change data capture. So we can push only change data from the SLT server at a client straight to our S3 bucket and not have to worry about grabbing deltas separately. It's straight change data. So once we get that into to our S3 bucket, as mentioned previously in the overall architecture design, we're able to, and I kind of like this this diagram here because it shows kind of the center, if you will, the VPC there, and our step function is the orchestration engine, and running those Lambda and glue jobs to grab data from raw, move it to provision or transformed, and then to the provision zones. Ultimately, we might end in Redshift, run analytics against that, or data that's also in the provision S3 bucket. We can handle analytics through Athena SageMaker, Spectrum. Oftentimes, we'll use to run through Redshift through to object stores. And then data visualization, as I mentioned, QuickSight is our very easy to integrate, very common. We love to stick with the AWS native services, but also we have the ability to integrate with Tableau, Qlik, Power BI, depending on if your client's tied into those services. So I think that's it for our presentation today. Thank you for coming. Again, it's very, very exciting to be back in person. We've got a team of folks at Accenture and our colleagues at AWS that continue to build out, make updates, and advance our data lake offerings. So please reach out to us if you need any help with clients, and we can be any assistance at all. Thank you.